Assalamualaikum and a good day. My name is Nurul Shazana binti Zainal Abidin. My matric number CB21029. So today I will present about our AI project. We have 3 team members, which is Waymin, Nurul Izzah and Nurul Shazana. We are from section 2 and our lecturer is Dr. Nur Shazwani binti Kamaruddin. Dataset that our group collect is about Alzheimer feature. This dataset we obtained from Kaggle, so here is the link. The objective of the dataset is to collect data related to Alzheimer feature for analysis purpose. So here is some of example of our dataset. As we can see from here, this dataset is grouping by non-demented and demented. And we have 9 variables, which is gender, age, year of education, socio-economic status, mini-mental state of examination, clinical dementia rating, estimate total intracranial volume, normalized whole brain volume, and the last one is Atlas scaling factor. So we move to our fuzzy logic framework. Here is our proposed fuzzy logic framework. So firstly, we'll do Alzheimer feature dataset, and after that we do data pre-processing, which is we do data normalization, define linguistic variable and terms, and after that we do fuzzification. In fuzzification, we do the design membership function, construct fuzzy rule, develop fuzzy logic system, evaluate the rule, combine rules of each rule, and after that we do defuzzification, which is convert fuzzy data to non-fuzzy value and implement classification, and lastly we do classification accuracy. So this is our membership function design. From 9 Alzheimer feature variable that I mentioned just now at dataset, we only take 5 variables to do the experiment, which is age, year of education, socio-economic status, mini-mental state examination, and the last one, clinical dementia rating. And the output is the risk output. So for the age, we classify to 3 stage, which is young, middle, old, and for years of education, short, medium, long, and for socio-economic status, low, middle, height, MMSE, low, middle, height, and the last one, CDR, which is questionable, low, moderate, and severe. And the output, we have 5 output, which is no risk, low risk, medium risk, high risk, and very high risk. So that's all from my part. I will pass to my friend.
My name is Waymin, matrix ID CB21015. So for this presentation video, it will be my turn to explain about fuzzy rules. So for the fuzzy rules for our risk of Alzheimer's fuzzy logic framework, we base it on the membership functions and factors that were covered earlier. And from this table that we can get from our report, we have 48 rules, and it uses 5 factors. So age, years of education, socio-economic status, MMSE, and CDR, and the output will be risk. So as we can see here, our rules, we focus more on the age, because old people, from what we gather from journal, age plays a big factor. Education can somewhat also bring a significant factor. Socio-economic status as well. MMSE is also plays a certain part of role, and CDR also is a contributing factor. So we give a higher priority to age and socio-economic status factors. So following that, we can go to our results. So to start off, we have classification result. So in our real data, from the data that we use to input inside the fuzzy logic framework, we have 107 data, and 48 of them actually is demented. This consists of actual demented status and converted. So what converted means in the context of the data set is that the patients that were being surveyed on, they got diagnosed as demented halfway through the study. So we count it as demented as well. And we have 59 non-demented. So our output data from our fuzzy logic, it outputs 49 demented and 58 non-demented, which is very close, but there's a caveat, because when we go to classification accuracy, we can see the true positive, true negative, false positive, false negative. So when true positive, it means that our data line up. The real data is 1, and our fuzzy logic output is also 1. The same goes for true negative, where the real data is 0, which means not non-demented, and our system output also give a 0. False positive is when the real data is 0, but our fuzzy logic give a 1 input, so it's like false positive. False negative is the opposite, when the real data is actually demented, but our output gives negative. So of course we will get 38 plus 48 plus this over the sum of everything, we will get 0.8037383. So this rounds us off to 80.37% accuracy of our fuzzy logic framework. So that's for my part. Thank you.
My name is Nurul Izzah binti Muhammad Usaimi, matric ID CB21046. I will be presenting on the coding for fuzzy rules using Python programming language based on our case study, which is Alzheimer features. In this source code, we'll be using the scikit-fuzzy library, which provide tools for fuzzy logic operation. Then we define the variable used in our fuzzy logic, Alzheimer risk. We have the following variables. The first one is age, EDUC for education, SES, socioeconomic status, MMSE, mini mental state examination, CDR, clinical dementia rating, and the last one is risk. And then we define the membership function for the age variable. We have 3 functions. We have 3 membership functions: young, middle, and old. For EDUC, education, we have 3 membership functions: short, medium, long. SES, 3 membership function: low, middle, height. MMSE, low, middle, height. CDR, 4 membership function: questionable, low, moderate, severe. And the last one, the risk, 5 membership function: no, low, medium, high, and very high. We use this command, variable name dot view bracket, for graphical representation. So here is the graph for age. This is graph for education, SES, MMSE, CDR, and the last one is risk. With the variable and membership function defined, now we can define the rules for our fuzzy. We have total 48 rules. Now we can input our 30% of dataset into this fuzzy. Then we set the input value for the current dataset. For this one, the index 0 stands for 84, index 1 for 16, index 2 for 1, index 3 for 30, and the last one, index 4 for 0. And then we compute the risk for the current data set. Risk underscore sim.compute. And then we get the computed risk value by printing the computed risk. So here is the result for the 30% of data. That's all from our group. Thank you.